Let's look at number 71. We will be graphing inequalities. So remember, when you're graphing a line and you're working with inequalities, you're working with greater than, less than, greater than or equal to, less than or equal to, and also is not equal to. So here we have y is less than 3x plus 4. And anytime you have a less than or greater than, it means that it does not equal the number, but it's less than the number or greater than the number. So if you're graphing a line per se, that line is going to be dashed. Do you remember in class when I talked about lines that are dashed? And then also, if you have an inequality where the line is less than or equal to, you will have a solid line because it's equal to the points on that line. Whereas this is less than the points on this line or greater than the points on that line. So let's just get to it and we'll talk about that. So here we have, I wrote up here our slope-intercept form. So remember, the b is the y-intercept and the m is the slope. So just by looking at this inequality, I can plot my points right away. So here's my y-intercept. It's going to be 4. So I'm going to plot my points 0, 4 for my y-intercept, 0 for the x, 4 for the y. And then I can see that my slope is 3, or 3 over 1. Rise over run, rise 3, run 1. So my slope is going to be 3 or 3 over 1. Well, it's going to be 3 over 1. So from my plotted point, 0, 4, I'm going to rise 3, 1, 2, 3, and run 1. That's where I know my line is. Again, I check, is it dashed or is it solid? It's less than, so it's going to be dashed. So I'm going to draw a line that has some dash marks. And y is less than everything that falls below this line. So you will then shade everything below in this first quadrant here and in this fourth quadrant here. A little bit of this third quadrant here. Oops, can you guys see what I'm doing here? Okay. Okay, let's look at number 72. So number 72 is y is greater than or equal to 1/3 x minus 3. So our minus 3 is our b, which is our y-intercept. So we're going to have 3, 0, negative 3. And then our slope, which is m, is right here, 1 over 3. So our slope is 1 over 3, which is rise over run. So let's go ahead and plot that point. And first of all, let's look at this inequality sign. It's greater than or equal to, so it's going to be a solid line right here, solid line. So let's plot our point 0, negative 3. And then we're going to rise 1 and run 3. We're going to draw our line, our solid line, and it's greater than or equal to, so it's going to be everything above this line. So you're just going to kind of sketch in, or shade in rather, everything above that line. Okay. I just want to go back up to number 73 really quick. I noticed that this line, that's not very kind of sloppy. So I'm going to just take my whiteout and let you know that that line does continue infinitely, and it should be a little bit straighter than that. Okay, that's all. Now on to number 73. Again, you should be able to, at this point, be able to simply look at this inequality and be able to graph it, okay, if it's in slope-intercept form. One thing about this inequality, however, is that it is not in slope-intercept form. Do you notice that? So if it were, our y would be all by itself on this side of the inequality. So we need to get it to that point. So I'm going to subtract 4x from each side to get my y all by itself on the left side. So those cancel out, the 4x and the negative 4x, and I'm left with y is less than or equal to, I'm going to switch up these two numbers, negative 4x plus 3. And I can do that, just switch the 3 onto this side and switch the negative 4x to that side by the commutative property of addition. Okay, remember that, where you can just go ahead and move all those numbers around when you're going to add a bunch of numbers together. You can just add them in any order you want, so you'll get the same answer. Okay, so now I can look at this inequality and decide my y-intercept is 3. So my coordinate is 0, 3. That's a 0, comma 3. Looks like a 9. And then my slope is a negative 4, or negative 4 over 1, the rise over the run. So let's plot my point first of all, 0, 3, 0, positive 3. And then my rise is a negative 4. So I go into the negative direction on my y-axis. 1, 2, 3, 4, and then I run 1. So my line is going to be solid, and it's going to be less than or equal to, so it's going to be everything that falls below this line. So I'm going to shade in everything below that line. So looking at number 74, they want you to find the range, the mean, the median, the mode. Oopsie. Sorry about that. For the following set of numbers. So the first thing I would do is, well, first thing you want to know is what each of these mean. And the range is the difference between the highest number and the lowest number. And the mean is the average of these numbers. The median is the middle number. And the mode is which number is used most frequent. The first thing I would do is arrange these numbers from least to greatest. Also keep in mind when you're writing out these numbers from least to greatest, just double check. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers, make sure you count 11 numbers this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's figure out what our range is. So our range is the difference between, I'm going to get a little piece of paper here, hang on. Okay, so I cut this little piece of paper here. So the range is going to be the difference between the smallest number and the largest number. Okay, so forget about all the numbers in between, and you're just getting the difference between the two. So 11 minus 3 is 8. So that is going to be the range. Our mean is the average of all these numbers. You're going to add up all these numbers, and I think I came up with 77. Let me double check. Yes, I got 77. So we have a total of 11 quantity of numbers. So 11 into 77 goes 7 times. So my mean or my average is 7. My median number is the number in the middle. So if we were to count back 1, 2, 3, 4, 5, here at number 7, 1, 2, 3, 4, 5, here at this 7, our middle number is 7. So that's also the median. And actually the mode is going to be, Toby's laughing at me. Anyway, the mode is going to be the number that you see most frequent, which is 7. For number 75, you're asked to design a bar graph for the following information. For this bar graph, be sure to find the mean of each data set. So I already added this data set for the girls, the boys, and the staff, and I came up with 26, 28 for the boys, 32 for the staff. And, well, first of all, a group of students and staff at FBS each shot 10 basketballs at the free throw line. There were 4 girls, 6 boys, and 5 staff members in all who shot these basketballs. So first you're going to find the mean for each group. So the mean for the girls is, let's say, we have 1, 2, 3, 4 girls. So we're going to divide 26 by 4. For the boys, we have 28. They shot 28 total, and they have 1, 2, 3, 4, 5, 6, 7 boys. You're going to divide it by 7. And for the staff, they shot a total of 32 baskets. Free throws, 1, 2, 3, 4. So let's go ahead and divide this out. So 4 goes into 26 6 times, minus 2. They shot a total of 6.5 on average. 7 into 28 is 4, and 4 into 32 is 8. So it looks like the girls shot an average of 6.5, the boys shot an average of 4, and us staff, we were just really on fire. We shot on average 8 baskets. So we're going to devise a bar graph for that. And so let's start with the girls. They shot 6.5. Here's the girls right here. So you find the girls, go up the line up to 6.5, which is halfway between 6 and 7. And just go ahead and kind of shade it in as long as you're there. And then for the boys, they shot on average 4. Sorry, boys. You didn't do too good. We all know that you do pretty well at the basketball games, though. Staff, look at us. You're the best around. Okay, we shot on average 8 out of 10 baskets. So that's a bar graph. You might want to make it a little more chunky. It's up to you. But that's how you can draw a bar graph. There's other types of graphs you can draw, diagrams, pie graphs. But that's all you'll need to do for the final. Only the numbers will be changed slightly. Okay? For 76 through 79, you will be finding the square root for the following perfect squares. So remember in class we talked about perfect squares, and this is basically a list of the perfect squares 1 through 25 here. So I have this on the board for you guys to look at and learn and memorize. And just by way of reminder, a square root is a number when you multiply it times itself, you get its square root. So you can undo that. So the square root of 4 is 2. How about the square root of 9? What number when multiplied by itself gives you 9? That's 3, right? So 3 times 3 is 9. How about 16? What number when multiplied times itself gives you 16? 4. And how about 25? There's one number that exists when multiplied by itself gives you 25. So the square root of 25 is 5. So for 76 through 79, we just did this one and we did that one as well. So what times itself gives you 4? 2. What times itself gives you 25? 5. What times itself gives you 100? 10. 10 times 10 is 100. And what times itself gives you 144? 12. Right? 12 times 12 is 144. So the square root of 144 is 12. Now I just kind of drew out a long addition problem with radicals, with square roots. So square root of 4 is 2. Square root of 25 is 5. Square root of 100 is 10. Square root of 144 is 12. And when we add these up, we can say 12 plus, here 10 plus 2 is another 12, so 12 plus 12 is 24, plus 5 is 29. For 81 through 83, you're going to simplify these square roots or radicals, and how you do that is the same way. I will remind you that if you have a negative inside the radical, so if this radicand, as it's called, is a negative, it does not exist. And that's why I wrote simplify. If no answer exists, state not real. So anytime you have a negative inside a radical, that does not exist. And it kind of like it's undefined, but it's not, there's no real solution for that. So you're just going to write not real. So there is a negative inside this radical, so it's not real. How about the next one? A negative inside the radical, not real. Doesn't exist. And I'll just backtrack a little bit and explain why. We know that the square root of 81 is a 9, right? So the square root of 81 is 9. And that's a positive 9. But if you have negative 9 times negative 9, you get a positive 81. And that negative 81 doesn't equal 81. So there's no way. You'd have to have a negative 9 times a positive 9 to give you a negative 81. And those are not the same. Remember, to find a perfect square, or the square root here, these have to be the same, and they're not. So it's not real. How about square root of, or the negative square root 16? So we know that the square root of 16 is 4, because 4 times 4 is 16. So you're going to write the 4 there. And as soon as you solve that, by order of operations, you solve that first, then you just drop the negative. Okay, moving on to 84, simplify. When you have addition inside a radical, you're going to solve that first. Okay, kind of like order of operations. You cannot add 16 plus, or square root of 16 plus 33. That's not right. The only way you can do that is when you multiply, like down here. Then you can pull those out and multiply those together. But you cannot do that with adding inside of a radical like that. So you must add these first, and you get 49. So the square root of 16 plus 33 is the square root of 49, and that is a perfect square because 7 times 7 is 49. Moving on, 77 minus 52, 7 minus 2 is 5, and 7 minus 5 is 2. So you get the square root of 25, and we already figured that out up here earlier, is 5. Square root of 9 times 25. Now this one you can multiply like this and pull them out because you're just multiplying these two. Square root of 9 is 3 times square root of 25 is 5. That gives me 15. How about 6 times 24? 6 times 24, if you multiply that out, is 144. And the square root of 144 is 12. Moving on, dividing radicals. So again, just solve for the square root of 64, which is 8, because 8 times 8 is 64, divided by the square root of 4, which is 2. 8 divided by 2 is 4. Moving on over here. So we want to solve for the square root first, okay? So I'm going to write that over. So 2 times the square root of 16 is 4, and then the square root of 4 is 2. You can either just cancel those out, those 2's out, or you can just say 2 times 4 is 8, divided by 2 is 4, or just cancel those out. You have 4 over 1, or 4. Oops. 490 through 92, you are going to be solving for x, not the square root of x. So we want to get x by itself and get rid of this radical. How you do that is you do to undo that is you do the inverse of the square rooting method. And that is to square root both sides. Okay? So what you do to one side, you do to the other. Now, keep in mind here that the square root of x means that you have a little 2 index here. It means that it's the square root of x. And when you square it, you cancel that out. So, and you actually cancel out that radical as well. So you're left with just x. Square this side, square this side. 4 times 4 is 16. Okay, same thing here. We want to undo this radical sign. So we're going to square both sides. Square both sides. Remember the index of 2 here allows me to cancel those out. And the radical, I'm left with just x. But I have to square this side. And x equals 400. Because 20 times 20 is 400. Next, moving on. I need to solve for x, but I have this square root here, so I'm going to square both sides by 2. Remember the little 2 index there, that all cancels out. I'm left with x is 15 times 15 is 225. Number 93, again, remembering PEMDAS or order of operation, go ahead and solve for what's in parentheses first. Square root of 81 is 9, minus the square root of 36 is 6. And then you can go ahead and bring in your 3 like that. Again, you have to solve what's in parentheses first. 9 minus 6 is 3. Bring down your 3, and 3 times 3 is 9. I made a mistake here, and I repeated the problems from earlier, number 90, 91, and 92. So you can go ahead and skip those. You won't see those on the final because we just did those. Okay. And let's look at number 97. So I want to solve for x, but I need to get rid of that radical. I also want to clear up my x, have it all by itself on this side of the equal sign. So let's get rid of this 3 by subtracting 3, canceling those out. What I do to one side, I do to the other. I have the square root of x equals 12. Remember how to undo this radical. You're going to square both sides. So square both sides. The little 2 index there allows me to cancel those out. X equals 144. Okay, so lastly, 98 through 100, we have